and he's going to be talking to us today about PyPy.js. Take it away, Ryan.
Details if you need to contact me. There we are. And as you just heard, I work for Mozilla. And if you've heard of Mozilla, it's probably because we make a pretty awesome web browser called Firefox, which, by the way, I'm using for my slides here today. But Mozilla as a company and as a worldwide community of volunteers, we're about a lot more than just, hey, let's make Firefox a really awesome web browser. At its core, the thing that drives Mozilla, and funnily enough, the thing that drives all of the material in this talk, believe it or not, is our mission to protect and promote the web. Right? The web as a shared global technology platform and as a resource for empowerment and innovation and opportunity. But when I say the web, I'm really talking about two kind of different but interrelated things, right? As engineers, we talk about the web, we tend to think of the technology stack of the web, right? Things like HTTP, HTML, JavaScript. But from a product perspective, or perhaps from a cultural perspective, the web also has a lot of rather unique properties. So one thing that people tend to love about the web is it's a really open system, right? If you want to publish something on the web, you don't submit it to the web store and then twiddle your thumbs for 6 months while someone on the other side of the world reviews your compatibility with the web's terms of service and rejects you on a technicality, right? You just get a domain name, you put it out there on the web, and you tell people to come and get at it. Likewise, if people want to consume your stuff on the web, they don't need a particular device or vendor or software. It's open for both producers and consumers. The web also has a pretty interesting kind of security story, right? It's all about running untrusted code that you've never seen before in a way that doesn't let people hack you, doesn't let people learn about your interactions with other sites and so forth. So the web is pretty unique. The problem is, I could very easily have labeled these columns thusly, right? There are a substantial number of people that are not terribly fond of the technology stack of the web. A lot of people go so far as to wish that the web would just hurry up and die so that we can replace it with something better, right? But the problem is you can't just throw away the tech stack of the web and keep all of the good cultural properties of the web. The two are, for better or worse, intertwined. So for all its flaws, I feel like the web really is worth keeping. And if we're going to keep it, then we should be working to try and make it better. And our CTO, Andreas, put this in a really interesting way. He says, for Mozilla, anything that the web can't do, right, anytime the web is not faster or better than a native technology, anytime someone reaches for a native technology because they think the web isn't up to the challenge, we should think of that as a bug. We should file it and we should work towards trying to get that fixed. Now, as a Pythonista, I have actually noticed, come to think of it, one of these bugs in the web. And maybe you've noticed it too, right? I want to code in Python. And that's kind of hard to do on the web right now, which brings me to the topic of this talk. This is my kind of experiment in what's possible in bringing Python to the web. It's a project called PyPy.js. I want to tell you a little bit about what it is, how it came together, and why on earth I'm working on this thing. So the what, in a sense, is fairly straightforward, right? It's the PyPy Python interpreter ported to the web. And in my head, in the talk, this is like a ta-da slide, right? I'm like, ta-da. If I could type when my hands weren't shaking. Python on the web, right? But thank you. That's very generous. But I feel like in this day and age, a lot of people have seen this sort of thing before, right? This is not the first project trying to put Python on the web by any stretch of the imagination. It almost certainly won't be the last. So I want to tell you a little bit more about why I'm doing something new. And for me, to be able to say that the web supports Python in a meaningful sense, you have to tick 3 boxes, which I want to explain by way of demonstration. The first point is that when I say I want to code in Python, I actually want Python, right? So if I have a number and I put it to the power of another number, like I should get a big number back in response. Now, if I were to ask JavaScript and its number model that same question, it would tell me the answer is infinity, which is off by a little bit. If I were in JavaScript and I did this, right, it wouldn't give me an exception, despite the fact that I almost certainly didn't want that. It would tell me infinity, which I also almost certainly don't want, but will probably go ahead and use. So one of the things I'm really interested in is getting a fully compatible Python environment. And it's not just the numbers, right? In Python we can do things like this. All right, equals some number, right? And we get it in the global scope. We can do things like sys.getFrame, and we can mutate the variables through that. Like all of these fun stuff that we've come to expect from Python, we should also expect from the web. The second point I'm really interested in performance. And this isn't to say like I want to do like super Fortran number crunching or anything like that, but if I go over here to my system Python, right, and I have some code, for example, this is a benchmark that ships by default with Python, which is really good for demonstrations. If I have some code that I can run in my native Python environment, it runs at about 140 PyStones per second. I should be able to go to the web, I should be able to do the same thing, and it should be able to run with comparable speed, right? As it happens in this case, it runs at significantly faster than the system Python. That's because this is PyPy, and PyPy is awesome, and if I do it again, it'll go even faster. But I would settle for comparable, right? The web shouldn't be blocking me from doing things fast in Python. The third thing I really care about, for want of a better word, I'm calling webbishness, which is to say, having a Python console on the web is a lot of fun. But I want something that's really of the web, right? I don't want to type into a little Python sandbox. I want to be able to like interact with the host JavaScript environment and do things like evaluate JavaScript and get JavaScript answers back, which are not Python numbers, they're these weird doubles. I want to be able to use all of the kind of browser and DOM interaction stuff that comes with JavaScript. So hello, ta-da. As you can tell, I'm very skilled at front-end development. I know all about alerting hello world. I want to be able to use, for example, utility libraries that are written in JavaScript and kind of have them operate in a sensible way. So, for example, I want to be able to use jQuery to find this console window. And then I want to be able to set its background color, again, if I could type, to something fun like chartreuse. If I want to get really fancy, I want to be able to define like a callback function in Python, right? And return, say, a cryptographically securely generated random number. I hope this is going to work. And pass that into JavaScript. Oh. Can anyone spot my bug? Ah, you random. I usually make a habit of pre-recording these things, but it'd kind of lose some of the appeal. All right. No! Sorry? Oh, God. I'm going to use up all of my time. But it's a fun demo, so I'm going to persist. There we go. Callbacks from JavaScript into Python. All right, so something that's really of the web in a meaningful sense. Now, as a general rule, right, if an engineer identifies 3 desirable properties of a system, they are about to ask you to pick 2 of them. And Python on the web suffers from this in a very serious way, right? There are projects like some of these that I've identified here that will give you a Python syntax, but will translate it more or less directly into JavaScript. So you get things like JavaScript's number model, JavaScript's object behavior, which runs really fast in the browser, but isn't Python in a very real sense. There are projects that put a lot more effort into being compatible with Python, but they pay for it because this stuff like generators and metaclasses and frames are really hard, so they don't run as fast as they could. And if you don't really care about being on the web, well, you can just run CPython or PyPy, right? And put a little shell window on it and shell out to it from your browser. My question is, can we hit all 3 of these? Right? And PyPy.js is kind of my experiment in trying to do that. Promising little demos aside, I'm going to leave that as an open question for now and come back to it because I really want to dive into the how, because I think it's really interesting. This project is essentially a coming together of 2 exciting, relatively new technologies, one in the Python world and one in the JavaScript world. The first of them is PyPy. So who knows about PyPy? Almost everyone. Awesome. PyPy is fantastic. It's a Python interpreter written in Python, which sounds like a terrible idea. It actually turns out to be a great idea because they have two tricks for making it run really fast, right? The first is they write it in a restricted subset of Python called RPython, which if you're a compiler genius or two and you exert a tremendous force of will in your compilation toolchain, you can translate RPython into C, which means you can compile it into a native executable. The other fun thing they have is a just-in-time compiler generator. Not just a just-in-time compiler, a just-in-time compiler generator. That means during this translation process from a Python interpreter in Python to a Python interpreter for C, you can kind of transparently put a just-in-time compiler in there. So at an extremely high level, eliminating a lot of very important details, the PyPy kind of toolchain looks like this. You start with a Python interpreter written in Python. You run it through this RPython compilation toolchain to get a bunch of C files. You compile the C files with a normal compiler to get a native Python interpreter. You feed your Python code into it, and this goes through the just-in-time compiler. It traces what the hot paths are, and it emits kind of this native approximation of the important bits of your code. So you wind up running kind of natively, which is why PyPy has this deserved reputation for being a very fast Python interpreter. From my perspective, the interesting thing about PyPy is that it's targeted as a platform for experimentation. Because it's written in Python, it's relatively approachable. I'm not going to say easy, but it's an approachable problem to kind of go and put a different garbage collector in there, or say put a different JIT backend in there, stuff like that. The second project I want to talk about quickly is ImScripting. Who's heard of ImScripting? Almost everyone, awesome. So ImScripting is a backend for the LLVM compiler toolchain. But instead of generating like x86 or ARM native code, it generates JavaScript, which again sounds like a terrible idea, but actually works out really well in practice. In addition to this, it's also basically a little simulated sandboxed POSIX environment for the web. So it has like sys.h, studio.h, stubbed out devices and get time of day and all of this POSIX-y stuff in a little sandbox on the web. And the guy that started this, a guy named Alon Zakai, when I met him and I had the opportunity to ask him about his inspiration for it, his explanation for this whole elaborate project was basically, look, I was working on this game, and it was in C++, and I wanted to run it on the web. And I said, okay. I salute you in your crazy compiler genius ways. In the process of trying to put this thing on the web, he happened to discover that inside of JavaScript, all right, there is this weird mix of high-level and low-level features, like closures that have really good kind of name reference protection, and 32-bit bitwise operators, bits and pieces like this. And it turns out that if you kind of carve out a strange little boundary around a lot of the parts of JavaScript and just use this one little subset, what you have is a 32-bit assembly language in disguise. And so the ImScripting project basically targets this subset. The way it works is as follows, right? You start with some code written in C or whatever language you can target LLVM. You run it through what looks like a standard cross compiler, right? Just a wrapper around the LLVM toolchain. It spits out some JavaScript. You put that JavaScript in your browser, and browsers have really powerful JIT compilers in them themselves. So the browser will take that code and turn it into a native approximation of the important parts of that code. So you wind up in the same place you would have if you were using something like GCC, but you're kind of indirecting through JavaScript in the browser. Now there's one obvious thing to do from this point, right? And that's to take these two projects and smush them together. What could possibly go wrong? So it looks like this, right? You have this Python interpreter that's written in Python. You run it through the RPython toolchain to get a bunch of C files. You run those through ImScripting to get some JavaScript, and you give the JavaScript to your browser, which turns it into native code. I can feed Python into that code. And because I started with an interpreter written in Python, it's not that big a deal to change its JIT to emit JavaScript at runtime for the hot parts of your code, which the browser will JIT back into native code. So you get to the place you want it to be, but going through the browser, which is lovely. Now, you started to clap then, but come on, be honest. Whose first thought upon seeing this diagram was approximately, that is awful? Good, that's fine, that's fine. I think that's fair, but I do want you to consider this, right? I've been calling this final thing native code, but it really ain't these days. right? When that code hits the CPU is going to translate that into its own internal representation of like micro operations and do like virtual register allocation, and it'll try and predict which branches your code is going to take and speculatively execute them and then stitch them back together if it doesn't work out properly, right? You know, this is not just, well, here's some native code and it runs in the silicon. So yes, this is kind of an awful collection of weird backwards compatibility hacks and layering violations. But the last 30 years of modern computing are built on exactly this kind of weird backwards compatibility. Yeah, it's awful all the way down to the silicon. So the question is not, well, look, is this a nice thing? Of course, it's not the system that we would build if we were designing an elegant cathedral from scratch. The question is it worth it? Now, as Mozillians, we have something of a habit of publicly tracking our performance benchmarks. So when the JavaScript performance wars were heating up, like the performance team at Mozilla made this site called arewefastyet.com, where you could track the performance metrics. Way back when Firefox was a little bit of a memory hog, let's be honest, the team working on that made this site called areweslimyet.com, where you could track the performance. So I've been working on this site called arewepythonyet.com, which doesn't fit on my slides, but that's okay, where you can go and you can check out our kind of performance benchmarks. Let me zoom out of that so we can see what's going on. So we have some performance tracking benchmarks, some startup overhead benchmarks. Let me give you the kind of highlights. First, the good bits. This is our performance tracking. This is performance of PyPy in the browser normalized to a native CPython interpreter. Across both Firefox and Chrome. And you can see down the bottom here, it says, oh, this is about 1.4 times slower than native, which is not too bad. If I take Chrome out of the mix, I'm happy to report that it averages out at 1.2 times faster than the native Python on my machine across these 8 benchmarks, which is pretty cool. Of course, if I compare it to a native PyPy interpreter, like the native PyPy is going to be faster than the web, but this one kind of outlier aside, which I really need to dig into, we're operating at between 5 and 10 times slower than a native PyPy, like with all of its amazing kind of years of work put into jitting, which I think is, for something running in the web, is actually pretty amazing. So that's the good. It comes with a cost, however. So this metric is measuring the size of the amount of JavaScript that you need to download to run this thing. And I don't know if you can read that on the graph here, but as a general rule, when you're measuring the size of your JavaScript assets in megabytes, you're going to have a bad time on the web, right? Part of the problem here is that this is, ImScripting is kind of designed for games, and in a game, it's okay to show a loading screen, right? It's like, hey, I'm loading like a couple of gig of image assets. You don't care about all this JavaScript. But for something like this, you'd ideally like to load a lot faster. There is actually some interesting new work going on inside ImScripting that will make this a lot smaller, and I think there's scope for doing some stuff inside PyPy. So that's something that's going to be pushing forward on this year. This is measuring the performance of that JavaScript bridge I showed you, basically the JS module. So it's measuring the overhead of doing like DOM manipulation in PyPy instead of in native JavaScript. And even if I take Chrome out of the equation, like we're still talking like hundreds of times slower than doing it natively in JavaScript, which is not awesome. Like, let's be fair. I think, somewhat naively, that this can be dramatically improved by teaching the PyPy JIT about JavaScript, more about JavaScript, right? But right now, like, it's kind of slow. So you can do fun demos and stuff, but if you were doing like serious DOM manipulation, you're going to pay a performance penalty. So if I return to the kind of question I had at the start, right, can we hit this middle ground, right? I'd love to be able to stand up here and say like, bam, PyPy.js, right in the middle there, ticking all 3 boxes. You're probably not going to be convinced after seeing those metrics, right? Honestly, it places closer to here, right? It's a really compatible, pretty fast Python environment that runs in the web and starting to push into kind of being really of the web. But if you take that home and you try and do like scripting the interactions on your website with it, you're probably going to be a bit slow right now. That said, I think there is a lot of ground for pushing further and further into that middle ground. So it'll be really interesting to see what we can come up with over the coming year. Okay, so The question you may have on your mind right now is why? Good, thank you. Yes, at least someone does. So my thoughts on the matter are almost entirely summed up by this Saturday morning breakfast cereal cartoon. And when someone asks you why, they kind of expect you to respond like this science advocate, like, why is this thing important? Oh, it has lots of really excellent applications in like energy and so forth. I'm a lot more like this guy. Oh, so I censored it for the code of conduct, but like, why is this important? Because it's awesome, it's fun, I want to do amazing stuff, right? That said, it is also, like, it also can be useful. So, as I said, like, the first thing people tend to want to do is something like this, right? Write script text equals Python. And I just want to reiterate one thing I said a bit earlier on in the talk. If you try and do this right now today, your users will not want to download 4 or 5 meg of assets before they can interact with your site. Like, they're going to have a bad time. That said, the load time of your site is not always in the critical path. So, for example, none of you had to sit around waiting for my slides to load. So if I scroll down to the bottom here, I actually scripted a bunch of my slides logic as a script type text equals Python. So it totally works. It's just got bad startup behavior. So it'll be interesting to see how useful we can make that. Following in that theme, if you want to do that today, like, you should probably check out one of these alternate projects. I hope to be competitive with them sometime this year. But specifically for scripting scripting tags on the web, probably check one of these out. I do want to try and do some other interesting stuff though, right? So people really like things like Py.to.exe, where you can take a native Python app, just kind of bundle it up and distribute it, right? Can we use this to build something like a Py2Web, like whether you've got a game or something written in Python, just like bundle it up, put it on the web, and it runs without any extra work, right? Can you then take something like a open web app manifest and add it to your app, and suddenly you've got an installable Firefox OS application, right? So you can reach some non-zero percentage of the worldwide smartphone market with your app. If you run that through our APK factory that Mozilla publishes, you can turn your Firefox OS app into an Android app and reach 1 or 2 more percent of the smartphone user base. The other thing that people have got going on that's really interesting, like the scientific community do a lot of great stuff with Python on the web, where these startup costs may not be a deal breaker, right? So, can we get more numeric stuff happening inside PyPy? Can we compile a bunch of Fortran libs for the web using ImScripting and like stitch this together into a fully web-based kind of scientific computing platform? Fun stuff like that. I want to call out explicitly the possibility of getting free stuff, right? So you may have noticed. Did I leave that as a bad color? Never mind. That I've been running in Python 2. It's just our version, right? Python 2, because PyPy supports Python 2 by default. But they've been working on this Python 3 branch. So if I want Python 3 on the web, well, I go and I check out this branch of the repo, right? And suddenly, I've got Python 3, right? Essentially for free, running in the web. If Python turns out to be not quite your thing, you can go to this repo and check it out. And anyone who doesn't recognize that weird prompt, this is a Prolog engine. And it's a proper one too. Like, if I ask it to solve for A and B, it'll tell me an answer, and I say that's not good enough, it tells me another one, and so on and so forth. It's a serious Prolog engine, and it runs in the web. And it jits to JavaScript at runtime, and I got all of that for free. Like, this worked literally the first time I tried it. I checked out that repo, I ran it through the compiler, and I put it on the web. So the reason I'm so excited about this approach is I think it really opens up the possibility of getting a lot more stuff onto the web once we put in the initial work. So let me conclude by simply saying I'd love to encourage people to adopt this attitude of filing bugs against the web. We really shouldn't settle for the web as a second-class computing platform. And if this turns out to be a failed experiment for one of a variety of reasons, and all I've managed to do is kind of identify some bugs in the web, it's like, well, this failed because the web sucks at X, Y, and Z, like, that'll be a success for me. And I want to try and inspire people to ask more of the web, and hopefully we really can start treating it as a first-class computing platform right across the spectrum of engineering. So thank you very much. Hopefully I've left some time for questions.
Okay, thank you very much, Ryan. We do have a few minutes for questions, and I believe there is a mic back here, so if you have any questions, please come ask them.
Have you tried it on Node?
Yes. You can actually npm install this thing I haven't published the latest version, but you can. And it's actually a lot easier there because of a variety of things with the way that ImScripting works. One thing I'd like to achieve this year is running a WSGI app under Node, kind of transparently, just for fun, just to see if it's actually possible.
So there's been 2 historical projects in PyPy. One is to use Clang and LLVM, and they failed for whatever reason. And there was also a JavaScript backend that died. Did you look at those? Were you able to reuse anything?
So the question was essentially, there have been LLVM backends and JavaScript backends for PyPy in the past. Did I look at them and did I learn anything? I did briefly. My understanding is that these sort of more or less predate the work that's been done in ImScripting, right? So the original JavaScript backend in PyPy was trying to target more or less high-level JavaScript. So like JavaScript objects and sort of more like the JavaScript that you write by hand. And I think it was eventually abandoned and ripped out and declared to be a terrible idea. And I agree, because Python is not JavaScript. The reason I sort of didn't hesitate to start this is that this kind of ASM.js and scripting, kind of the web as a 32-bit CPU is pretty new. And so it brings with it a different set of capabilities and trade-offs that seem to be working out okay in practice.
Yeah, hi. I'm curious. A few years ago, I wrote, just for several reasons, out of the Python interpreter, I wrote a Python package that was able to interact with the JavaScript core engine, and through, at that point it was WebKit GTK was the easiest thing I could use to bring up a browser through the browser window through Python. I was able to write code that was directly able to interact with JSON. JSON can interact back with the Python code. I'm wondering, why don't we explore options of actually putting a Python interpreter sandboxed appropriately into the browser and use technologies that would run things even faster than JavaScript, because it's running direct Python interpreter in the browser itself, and it actually can interact with any JavaScript at all that you put into the web page.
I would love to see that happen. The difficulty is no one is capable of doing that themselves, right? So, I mean, Google and Chrome essentially wanted to do the same thing with Dart, right? They're like, this is a better language than JavaScript, and we want to ship this natively to the web. And despite kind of the clout they have with Chrome, they haven't been able to do that. And so it's not kind of within any one web vendor's power to try and force this forward on the web. And if we ship we ship Python inside Firefox, nobody's going to use it because it's not available in Chrome, it's not available in Internet Explorer. My kind of secret hope is that we can ship this kind of JavaScript shenanigans as a fallback. Right? So if a browser was able to ship a native implementation of a language, then you could use it. But if they're not, then it's okay to fall back to this kind of compiled JavaScript implementation. That's one potential way to kind of build up collaboratively out of the situation we're in right now, which is this kind of three-way Mexican standoff where no browser vendor wants to, or every browser vendor wants to improve stuff, but in different ways.
So one use case that we've used IPython Notebook for is helping people learn Python right from the very beginning. So introduce them to the syntax and how it feels to make things happen without the burden of setting up their systems. But obviously, part of the challenge there is that someone has to run the IPython Notebook somewhere, and then that system is basically insecure. So you alluded to this, but I'm curious, maybe who's working on it or what state it is in, of actually, sure, the load time will be large, but in this context, that's okay. They load it up at the beginning of the day, and then, I mean, even just using the sort of example that you're showing would be great, but how is the work progressing with combining it with IPython Notebook, and is that actually something that's going to happen? And yeah, is it production ready for those sort of purposes? Or even your own library being production ready for those sort of purposes?
So part of the reason I put that mention of IPython on my slides is I'd love to find someone here at the conference who's interested in that and make it happen. I'm not aware of anyone working on that right now. I just think it'd be cool. And I don't think it would be, like, the IPython stuff is really well factored. It's got excellent kind of protocols for doing communication between the front end and engines and so forth. So I think it would probably come together quite nicely. But I don't have the kind of knowledge or time to build it myself. I would love to connect with someone. If someone's interested in trying to plug this into IPython notebook and so forth, let's connect somewhere at this conference, because I think it'd be great.
Much again, Ryan. Let's give Ryan a round of applause.
Thank you.